Hi class, in this video we're going to set up disk partitions. So the first thing I'm going to do is go to our classroom map. And we're going to look at our file server. The IP address is going to be 10.0.0.5. I've already booted that machine up, so the next thing I'm going to do is assign the IP addresses and join it to the domain. I just want to point out that my DC has to be running before I can join it to the domain. I'm going to sign in. Again, 10.0.0.5. For ACIT, we're using a 24-bit subnet mask. Our gateway, which is controlled by ACIT, is 10.0.0.1. And our DNS server is what we set up in our first lab, which is my domain controller. That has an IP of 10.0.0.2. So there's my domain controller. Let me just show you that. So I'm in the domain controller. I'm going to launch the DNS utility. And this machine knows about Contoso.com. So it's going to be able to resolve any name for Contoso.com to this machine. So I'm going to go back to my file server. Click OK. Close out of the IP settings. Loosen up my firewall. Now I'm going to rename it and join it to the domain. It's going to be called FS. If you don't have the DNS pointing to the DC, it's not going to be able to find out who the domain controller is for that domain, and it will fail to join. So if you're getting errors joining to the domain, most likely you have the DNS pointing to the wrong machine. I'm going to click OK, 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 and close, and then reboot. OK, 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 and close. Then restart it. Now I'm going to sign back in as a domain admin. So click Other User. Okay, sorry class, I stopped for a minute to answer an email. Okay, so now my computer is joined to the domain. I'm signed in as a domain admin. All my IP settings are set. So I'm going to click start. Excuse me. I'm going to right click start and go to disk management. Now I'm going to go back to lab for a moment. So on this machine, unlike all the other machines, I've added 4 hard disks. One hard disk has the operating system on it and 3 are blank. So I'm going to go back to that machine. So there's my one hard disk with my operating system on it. And there are my 3 blank disks. We're going to look at these disks as if they were brand new, never been used before. And I'm going to right click, bring the disk online, then initialize it. I'm going to do a GPT. Most machines we buy nowadays are Generation 2 machines, which require GUID partitioning table. The GUID is a global unique ID that identifies each partition. In a GUID, you're going to have a partition on your operating system disk up here. Called an EFI system partition. These are Generation 1 machines. In that EFI system partition, it's going to hold your GUID partitioning table, and we can have unlimited number of partitions on a disk with a GUID that's using a GPT partitioning table. Right now it's not initialized, so I can't see that partition. Generation 1 machines have something called an MBR, which is the first 512K of a hard disk, and it's called the master boot record. It holds your partition table and it also holds a little program called a bootloader. With an MBR partitioning scheme, you can only have 2 partitions per, you can only have 4 partitions per hard disk. So there's a limit to the number of partitions you can have with the MBR. With a GPT partition disk, we can have unlimited partitions. For this lab, it really doesn't matter what we choose, but this utility, when I initialize it, senses that this is a Generation 1 machine and it makes an MBR. We can use GPT partitioning scheme on a Generation 1 machine as long as it's not the system disk. On a Generation 2, you need to have a GPT partitioning scheme for the boot disk. In this case, I have an MBR because this is a Generation 1 machine for the boot disk. In Gen 2 machines, you're going to have a GPT partitioning scheme for the boot disk. The other disk, as long as they're not boot, they can be either MBR or GPT for Generation 1 or Generation 2 machines. So in this lab, it doesn't really matter how I partition it. I can just stick with 4 partitions. I can do this lab with 4 partitions per disk, so this would be fine. But if you needed a lot of partitions, you might want to go with GPT. I'm just going to do GPT because that's the more modern partitioning scheme. So I'm going to click OK. I'm going to do the same thing for the other disk. I'm going to right click the label on the left, bring it online, then I'm going to initialize it GPT. Bring it online, then initialize it. And I just want to point out that older versions of Windows won't understand GPT. So if this is a portable disk and you're going to bring it between operating systems, you might want to stick with MBR. I'm going to click OK. So I have 3 disks. Guys, and I only have 20 gig disk here just because of the size limit imposed on us by ACE-IT, but it should give you an idea how to do partitions. So I'm going to do a single simple partition. So I'm going to right click, create a new simple partition. They're calling it volume here. It's really not a volume. I don't want to have that discussion. This is a basic disk, so it's going to be a partition. Click next. I'm going to use the entire disk. I'm going to assign it a drive letter of D, the next available drive letter. And then I'm going to give it a label. It doesn't really matter what label you give it. Sorry, and I'm going to do a quick format, meaning I'm only going to format the beginning of the hard disk. I'm not going to rewrite the entire hard disk. It really saves time. If I uncheck this, it's going to take a long time to format because it writes to the whole hard disk. There, it's only writing over the partitioning table. Okay, so now we have a simple hard disk. I'm going to go here, a simple partition. They're calling it a primary partition. If I go to this PC, I can see that disk, I can write to it, things like that. So now I'm going to go to my C drive and create a folder called disk 2. Now, because this is formatted NTFS, I can right click and change drive letters and paths. And I'm going to still leave it mounted to the D drive, but I'm also going to mount it to a folder. I'm going to mount it to the disk 2 folder. So now I can get to that hard disk by either going to disk 2, that's called the mount point. I'm going to create a new file here. This is a simple text document. Or I can get to the hard disk. The other mount point is the D. So I can get to that partition in 2 ways. Through the D drive or through the folder. This is the way Linux and Unix systems mount partitions. They mount it to a folder. Windows generally mounts to the D drive to a drive letter. That's called the mount point. The reason why you would want to do this on a Windows machine is you might have some old legacy application that you don't have the ability to change drive letters. So you can create a folder and have that application go to the C drive and then go to that folder to access that partition. And also, sometimes you have people that are just not tech savvy and they just don't understand how to get to different drive letters. And if that's the case, you can just create a partition, mount it to a folder, and at that point they can go to that folder to access the files on that drive. I'm going to go back to disk management. I can also change drive letters and paths. I don't need it mounted to both. I can only have it mounted to a folder if I wanted to. So right now, I got rid of the D drive. So the only mount point that I have is the folder under the C drive. That's the only way to access this partition now. Before, I had just the drive letter. Then I had the drive letter and the folder. Now I have just the folder. That's called a primary partition on a basic disk. I'm going to delete that now. I'm going to delete the volume. I can also, I'm going to create another simple volume, just like I did before. And I'm just going to give it a different label. I hate this keyboard on this laptop. I'm just going to call it spanned, and I'll show you why in a moment. So now it's still a primary partition on a basic disk. If I right click it, I can extend the volume. For whatever reason, I need more disk space, but I have no space left on this physical disk. So what I'm going to do is I'm going to extend it to the second disk. That right there is going to convert this disk from a basic disk to a dynamic disk, and this one as well. And at that point, it will no longer be a primary partition. It's going to be considered a span partition. Click Next. It's asking what disk do I want to extend it to. I'm going to click Add. I'm going to extend it to disk 2. I'm going to use all the available space on disk 2. Next, then Finish. So now it's giving me a warning that to do what I want to do, I need to have the disk set up as a dynamic disk. Once I set this up as a dynamic disk, a lot of other operating systems won't be able to read this disk. This disk won't be read. This disk won't be readable until the operating system is fully booted, because at this point I need special drivers to access this disk. Click Yes. So now it's no longer considered a primary partition, it's called a span volume. If I delete this span volume, again, I can mount this to a folder or to a drive letter. If I wanted to, I could extend this to their third disk. This is offering no sort of redundancy, no protection whatsoever. If I lose one disk, I lose the data from both disks. So you need to be careful with this. Professionally, I've never used this. This is kind of a software solution to do things. I'm not a real big fan of it. Again, because if you do lose one disk, you lose everything. You can mitigate that by doing backups. I cannot stress the importance of backups. I know a lot of people who've gotten fired because they didn't do backups. So I'm going to delete this one. I'm going to delete this up here. And look what happens when I delete it. It deletes them both. So you need to be careful with that. So the next one I'm going to do is something called a mirror. And I pulled this up on Wikipedia. A mirror is a RAID 1 device. So basically, when I create a mirrored volume, and again, it needs to be a dynamic disk. Just like span volumes, I can't use basic disk. When I delete a volume, it goes back to basic. Incidentally, once you convert to basic, you can't go back unless you delete all the partitions. You can go from basic to dynamic, but you can't do the reverse. The only way to do it is to delete all the data off the disk. And then it goes back to basic. So with a mirrored volume, or RAID 1, basically every time I read from the disk, I read from one disk. When I write twice. I write to two different disks. I need to have the same amount of free space on both disks to set this up. And it adds redundancies. A lot of small servers that you buy for like small companies, generally come with 2 discs, and they're automatically set up as mirrored 1. So if one disc goes down, the other disc can handle the load. Because when you read from one disc, whatever disc is available, or when you write to both discs. So you have redundant data. In a mirrored volume, if one disk goes down, a lot of times you have this feature called hot swap. While keeping the computer running, you can pull out the bad hard disk and replace it with a good hard disk. At that point, the system will resync the hard disk. A lot of times we use hardware solutions, meaning the RAID is handled by the controller card, not by software like I'm using right now. I think a hardware solution is better than a software solution. It tends to be a little quicker. So I'm going to right click. I'm going to create a new mirror volume. Click next. It's asking which 2 disks do I want to mirror. I'm going to use disk 1 and disk 2. Click next. Assign a drive letter or a folder, whatever I wanted to do. Or I don't have to assign a drive letter at all, meaning if I don't do this, there's no mount point. So no users can access that partition until I mount it to something, either a letter or a folder. I'm not going to bother giving a label, but you can give it a label, and I'm just going to do a quick format. In reality, I probably wouldn't set up a mirror doing a quick format, but just to make this video short, I'm just going to do a quick format. Finish. And it's saying I can't have a basic disk, I have to have a dynamic disk, it'll convert it. While that's doing its thing, because it's going to take a while to sync up, I'm going to create another. No, I can't do anything until that's done. Okay, so now I have a mirrored volume. Keep in mind, guys, I've lost 50% of my disk space. So even though I use 40 gigs of disk space, I only have 20 gigs of writable space because everything is redundant. I just want to point out something else. I'm going to right click, create a new simple volume, which I said is not a simple volume, it's a partition, a primary partition. It's going to assign it a drive letter of E. So right now it's a primary partition. If I right click the disk and say convert to dynamic disk, it becomes a volume. Disk 3. Yes, it will convert it. And it's going to convert it to a dynamic disk. Now you can see it's actually called a simple volume. So on a basic disk, a partition is called a partition. We have 2 types of partition: primary partition and extended partition. And basically what you can do is you can have 4 partitions, 4 primaries or 3 primaries and 1 extended. And if you have that 1 extended, you can create a bunch of logical partitions under that extended. So if you need more partitions, you create 3 primary, 1 extended, then you create a bunch of logical partitions under the extended. Nowadays it's kind of moot because if you really need more than 4 partitions, just create a GPT disk. This right here is MBR, these 3 are GPT. So I just want to point out the name difference. A primary partition, the disk is basic. A simple volume, the disk is dynamic. I'm going to delete that. So we have a mirrored disk. So every time I write to this disk, it writes it to both physical disks. Every time I write to this partition, it writes it to both physical disks. I have the ability, let's say I made a change and it wasn't right, and I wanted to keep a snapshot of that change. I could break the mirror if I wanted to. And at that point, there would be two separate partitions. And whatever data I had on one partition would be on both at that point. But from this point on, every time I wrote to the D drive, the change would only be there. If I wanted to, I could remirror it. But I couldn't use a disk that had something on it. So if I wanted to recreate a mirror, I would have to delete the partition, then I can use that disk to reestablish a mirror. So at that point, I would be wiping any data out on disk 2. Then whatever data is on the E drive will be copied down here. You see how it says it's resyncing? If there's a lot of data here, it would take a long time. So right now, I've got a warning symbol that disk 2 is out of sync, meaning it doesn't know about all the data on the E drive. And that's going to take a while, even though it's blank, because it really does a bit by bit copy of the disk. So I'm going to pause the video for a minute while it finishes the resyncing. Oh, actually, before I pause it, I want to point out, in the past, when I would lose a disk in like a mirror or RAID 5, and I haven't gotten to that, sometimes it would take 2-3 days to sync. While it's syncing, I can still use the E drive, so my machine can be up and running while it's syncing. I don't need to stop using the machine while it's syncing, especially if it's a hot swap, meaning if this disk went down and I broke my mirror. You don't need to break your mirror if a disk went down, but you could. Or if it just went down and I replaced this disk and it's resyncing, I can continue to use the computer while it's syncing. Okay, they're synced now. So if a disk fails or you reestablish a mirror, it's going to take a while to sync the disk. So I'm going to delete this. Sorry, that's my cat in the background. Delete the volume, which will delete both. And now we're going to create something called a RAID 3. Last one we did a RAID 1. Guys, you never see RAID 0 or RAID 2 or RAID 4 anymore. Basically, what you see is RAID 1, RAID 3, RAID 5, and RAID 6, which I can't do on our current setup. So RAID 1 was a mirror. RAID 2 is a byte level stripping. So basically, you need at least 3 disks. And here's how a RAID 3 works. When I write data, it's going to write it to here. Then while it's going to send this signal to write to this disk. Then it's going to take the next piece of data and write it down here. To the next piece of data and write it down here. The reason why we have this RAID 3 is to improve performance. So if you're doing video editing, you want to set up a RAID 3 because it really improves performance. The slowest part of your computer is those mechanical hard disks. And it takes some time to write to those mechanical hard disks. So the computer will send up the first piece of data to this disk, and while it's busy writing, it'll move on to the next disk and write some there as well, then write to the next one while the first two are busy writing. So it's going to improve performance. Then after it's done writing all the data, it's going to run a little algorithm and put a parity value on the next on the next available disk. At that point, if one disk is lost, excuse me, I'm talking about a RAID 5 right now. I'm doing a RAID 3. Sorry. It does what I just described, but it doesn't do any sort of ability to rebuild the data if one disk is lost. When you're doing a RAID 3 and one disk is lost, you've lost the data on all three disks. So it only improves performance. There's no sort of reliability there, no redundancy whatsoever. So we're going to set that up. So I'm going to right click and do a stripe volume. That's a RAID 3. I'm going to use all three disks. I'm going to use the full amount on all three disks. Give it a drive letter. I'm going to do a quick format. And to do that, it needs to be dynamic disk. So there's three disks. And I've lost no disk space because there's no sort of redundancy. So basically, it's going to write data a little bit here while it's busy writing, move on to the next disk, then move on to the next disk, and it's just going to keep filling up the disk in a striping pattern. And it's going to improve performance. I have no disk loss. So I used 60 gigs of bits of data, space on the hard disk. I can write 60 gigs of disk space. We don't use this too much anymore, but I just want to point it out that it exists. It's going to stripe across all three disks. The next disk we're going to have set up is a RAID 5. This is kind of old school. We used this in the early 2000s, late 80s, all through the 90s. Don't really use it anymore. A lot of times if you need good disk speed, you get SSDs. You don't worry about the disk speeds of these mechanical disks. So now I'm going to create a RAID 5. A RAID 5 is kind of like a stripe volume, but it adds something called a parity to it. So in this case, I'm using 3 disks, so I'm going to lose a third of my disk space. If I had 4 disks, I would lose 25% of my disk space. If I had 5 disks, I would lose 20% of my disk space, because at the end of the striping, it's going to add a parity. And when it adds that parity, it's going to use a little portion of that one disk. So if I'm striping across 4, it's going to use the 4th disk as parity. And at that point, if I lose any one disk, it'll be able to look at the parity and figure out what data was on the disk that I was missing. Now, it's not always one disk that's going to be the parity. It's going to be at the end of the write. So if I write across all the disks and it ends up on the second disk, the third disk will have the parity bit. If I write across all the disk and I end up on the first disk, the last piece of data is written on the first disk, the second disk would contain the parity. So the parity isn't saved across all the disk, saved on one disk, it's spanned across all the disk. And again, this is going to take a minute to come up. So this will add the benefit of the striping, plus it'll add that parity so you have some sort of redundancy. If you lose one disk, it'll be able to calculate what data it was missing. If the disk that you lost contains a parity bit, then I don't need to figure anything out because the other two disks contains the data. If the disk that is lost contains a piece of data, it'll go to the parity for that piece of data and find out what was on it so it can rewrite it once you replace the disk. Even until you replace the disk, it'll be able to dynamically figure out what was on that disk. This only will allow me to lose one disk. If I had a RAID 6, which this system can't handle, I can't do it software-wise, I need a dedicated controller that handles RAID 6, a dedicated hardware controller, then I could lose two disks, because what it does is it does a double parity disk. And again, it's distributed, meaning it's not always on one disk, it's on a bunch of different disks. Wherever the last piece of data was written, whatever disk that was, the following disk will contain the parity. And this, again, provides fault tolerances, and you can lose two drives. And you have the benefit of the striping. This is fault tolerant, meaning you can lose one disk, but still get the benefit of the parity. So I'm going to pause the video while this is building it. Sorry guys, I got confused. RAID 0 is the stripe volume, because we didn't lose any disk space. So basically, that's the stripe volume, RAID 0. So what we're doing is RAID 0, stripe volume, RAID 1 was the mirror, and RAID 5 was what we're doing now with the stripes and the distributed parity bit. So the last thing we did was RAID 0. Before that, we did the RAID 1. And now we're doing RAID 5. And again, we don't really use this anymore. It's kind of going out the window because of new technology. But I just want you to be aware of how to do it and what it is. Okay, guys, this is just going to finish up. Again, I'm going to lose a third of my disk space because I only have 3 disks. And that third disk or the second disk or whatever disk the data ends is going to contain the parity bit. So I've lost a third of my data because of the parity bit. If you had 4 disks, you lost 25% of your data. 5 disks, 20% of your data. So the more disks that you add, your percentage of disk loss goes lower. I'm going to pause the video and wait for this to be done. Okay, guys, while we're waiting, I just want to point out, again, just to reiterate, because I know this is probably confusing. The Windows software solution for handling these disks only supports RAID 0 for striping, RAID 1 for mirror, and what we're doing right now is RAID 5, striping with the parity. It's at 66%. Now after the formatting, it's syncing the data, and that takes some time as well. So I'm going to pause the video some more. We're at 66% resyncing. Still pausing. 72%. Okay, it's done formatting and resyncing. So if I go to this PC, I can see that I use 60 gigs of space, but I only have 40 gigs available to me because of that parity disk. So RAID 5 provides the speed of the striping, but adds a little bit of fault tolerance with that parity. With that fault tolerance, you're going to lose some disk space. Okay, these are some old school methods of creating partitions. We don't really use these as much anymore. A lot of times the physical disks aren't even in the machine. They're on a server somewhere else and being mounted remotely. But I just kind of wanted to give you an overview of the old school methods of creating partitions. Most likely the only partition you'll be creating is just a simple volume or a primary partition and leaving it at that. But you are aware of these other type of partitioning schemes. Okay guys, that's going to be it for this lab. I'm going to delete these because we need to use these disks in our next lab, and I will see you then. Thank you.